rates of change. Suppose y is a quantity that depends on another quantity, x. Thus y is a function of x, and we write y is f of x, f being the rule that x is subjected to find y. If x changes from x1 to x2, then the change in x, it's also called the increment of x. Delta x is x2 minus x1. And the corresponding change in y, delta y, is fx2 minus fx1. Okay, so this is just the terminology, the increment. The difference quotient is delta y over delta x, which is fx2 minus fx1 over x2 minus x. So that is the difference quotient. So delta y, that's the rise over the run. It is called average rate of change of y with respect to x. Average rate of change of y. Notice average rate of change is always spoken over an interval, and that represents slope of the secant line. Okay. By analogy with velocity, we consider the average rate of change over smaller and smaller intervals by letting x2 approach x1. So as the denominator gets smaller and smaller, that is as x2 approaches x1, you take this particular quotient, take its limit, okay, difference quotient, take its limit as the denominator approaches 0. What you get is instantaneous rate. So instantaneous represents the slope of the tangent. All right. Average represents slope of the secant. Now we recognize this limit as being the derivative at x1. We know that one interpretation of the derivative f prime a is as the slope of the tangent line. We now have a second interpretation. Derivative f prime a is the instantaneous rate of change of y equals fx with respect to x. All right, when x is a. Connection with the first interpretation is that if we sketch the curve y equals fx, then the instantaneous rate of change is the slope of the tangent to this curve. Okay, so that's your curve, that's your tangent. That slope of the tangent is the instantaneous rate of change. Okay, as opposed to, say, if I drew a secant line from P to Q, then that would give me average rate of change. When the derivative is small, the curve is relatively flat and the y values change slowly. In particular, s equals ft is the position function. If s equals ft is the position function of a particle that moves along a straight line, then f prime a is the rate of change of displacement. Okay, derivative represents rate of change of displacement s with respect to the time t. F prime a is the velocity. Speed of the particle is the absolute value of the velocity. All right, absolute value of the velocity is speed. A manufacturer produces bolts of fabric with a fixed width. Cost of producing x yards of this fabric is given by this variable c, which is a function of x. C is given in dollars. What is the meaning of the derivative f prime c? What are its units? What do these mean? Numbers mean? Let's think about it, right? Derivative f prime is the instantaneous rate of change of c with respect to c. F prime x means the rate of change of production cost with respect to the number of yards produced. Rate of change of production cost. All right. So the units for f prime are the same as the units for the difference quotient. Since $C is measured in dollars, delta C is measured in dollars, delta X in yards, the units for f prime, that is the rate of change, okay, of the production cost. It is dollars per yard. So what does it mean to say F prime 1000 is 9? It means that after 1000 yards of fabric have been manufactured, the rate at which production cost is increasing is $9 per yard. Okay, because that is rate of change of production cost. So the production cost, because this is positive, we are expecting it to increase by $9 per yard. Okay, the rate basically. So F prime of 1000 is approximately delta C by delta X, which is, so since delta X is 1, say let delta X be 1, you can compare it with 1000, right? So compared to 1000, delta X is small. F prime X is same as approximately delta X. So that means what? The cost of manufacturing the 1000th yard or the next one, the 1001st yard, is about $9. Okay, that's what this means. So at the 1000th yard, the next yard, you expect it to cost $9. What does this mean? This means the cost of manufacturing the 51st yard is probably higher than the cost of manufacturing the 501st yard. Well, possibly because more larger your factory, the more efficient you get. Okay, so it may happen that F prime at 5000, by the way, at some point, if your factory is too large, you are probably getting to be inefficient also. So probably the 5001st yard is more expensive to manufacture than the 501st yard. Okay, that's also going a possible feature. All right, so this completes all the lectures for section 2.1. The next videos will cover problems from web work on section 2.1. Until then.